Kia ora, and welcome to a lesson on Cambridge Mathematics P3 partial fractions. So today we're going to be looking at what are partial fractions and how to calculate partial fractions that are given to you in different situations. A partial fraction is where you take a single algebraic fraction and you split it into two or more what we call partial fractions. So to understand that, you first got to think about how you form your algebraic fractions to begin with back from your GCSE or AS level times. So let's have a look at a question where you make it into a single algebraic fraction, and then we can talk about how we can go from that single algebraic back to its original part. So if I had 5 over x plus 3, and I'm adding 4 over x minus 2. You may remember how to do this, hopefully you do, but you can simply take both denominators for each of these fractions and multiply them by each other to form a single algebraic fraction for x plus 3, x minus 2, and then you'd have x plus 3, x minus 2 on the other fraction. If I've multiplied my left fraction by x minus 2, I also need to multiply the top by x minus 2. If I multiply my right fraction by x plus 3, I also need to multiply the top by x plus 3. Now I have it like this. I can write it as a single fraction, which would be 5 lots of x minus 2 plus 4 lots of x plus 3 all over x plus 3 x minus 2. I can then expand my brackets and simplify that down, which would give me 9x plus 12 over x plus 3 x minus 2. So here we've taken separate fractions and made it into a single algebraic fraction. What we do in partial fractions is we reverse this process. Okay? The way to do that is to follow a sort of formula or a kind of an approach, which is where you say, if you've got a algebraic fraction, which looks like this, where there's something on top, and you have two distinct brackets on the bottom, you can split that into a partial fraction which looks like a over ax plus b, our first bracket, plus b cx plus d, which is our second bracket. So we've just split those two brackets apart and say we can write it as a fraction where we've got something over that and something else over the other one, which is basically what we got here. We ended up with a combined x plus 3 x minus 2, whereas we started with x plus 3 x minus 2. If I was to include an extra bracket on here, such as if I had px plus q over ax plus b, cx plus d, and ex plus f, then I can just expand this to become a over ax plus b plus b over cx plus d plus c over ex plus f, and so on and so forth. Okay, if I had extra brackets, I could keep going on with this process. So how does this look in principle, and how do we then use this to calculate our values of a and b, because that's also going to be important for this. So let's have a look at an example here. We're going to express 2x minus 13 over 2x plus 1 x minus 3 as partial fractions. So the first thing to do is to say how I can write this. So 2x minus 13 over 2x plus 1 x minus 3 can be rewritten as a over 2x plus 1 plus b over x minus 3. Okay, now that I've identified this, I can multiply through by a value to help me solve for a and b, and then we'll look at how we can use that part to get our a and b. So we want to get rid of our fractions basically to find a and b. So what we're going to do is we're going to multiply everything by our quadratic bracket on the bottom. So we're going to multiply everything by 2x plus 1, x minus 3. So when I multiply the left hand side, this single fraction, by 2x plus 1, x minus 3, it's going to cancel out both brackets, leaving me with 2x minus 13. When I multiply my a over 2x plus 1 by this, the 2x plus 1's will cancel out, but then I will be left with an x minus 3 on top. So this becomes a x minus 3. When I multiply my b over x minus 3 by this, the x minus 3's will cancel out, but it will leave me with a 2x plus 1 with my b. So I end up with this here. Okay. To solve this, I will solve it via substitution. Okay. Because I've got multiple variables here, I've got x, a, and b, I'm going to substitute in a value of x which will eliminate my x variables because I'm replacing my x, but it will also eliminate either my a or my b. And the way to do that is to remember your rules of multiplication. So I've got a times x minus 3 and I've got b times 2x plus 1. So if I can make my x minus 3 become a 0, I will get a times 0 and eliminate my a. So what would the value of x be that would allow me to eliminate this bracket here? Well, if x was 3, this bracket here will be 0. So what does that look like? So 2 lots of 3 minus 13 is equal to a lots of 3 minus 3 plus b 2 lots of 3 plus 1. Okay, and then that will become 2 lots of 3 minus 3 is minus 7. Minus 7. A 3 minus 3 becomes 0. That disappears. And then b 2 times 3 plus 1 is 7b, giving me a b value of minus 1. Okay, so my b is minus 1. Now I found b, I need to find c. So, sorry, not c, a. So I need to do something that will eliminate my b. So how can I make this bracket, 2x plus 1, become 0? Well, if I want 2x plus 1 to equal 0, then 2x would equal negative 1, so x must be minus a half. So I'm going to now substitute in minus a half into my equation. So x is equal to minus 1 over 2. And let's substitute that into our 2x minus 13 equals a x minus 3b 2x plus 1, giving me 2 lots of minus a half minus 13 is equal to a minus a half minus 3 plus b 2 lots of minus a half plus 1, which again this will cancel out to become 0, that's the whole point. 2 times minus a half minus 13 becomes minus 14. And that is equal to minus 3.5a, or minus 3.5a. I'm going to write it as minus 3.5a, which gives me an a equal to 4. Okay, now I found my b and I found my a. I just need to go back to my original thing that I wrote up here and write that, write 2x minus 13 over 2x plus 1x minus 3 in that form. So the final solution is 2x minus 13 over 2x plus 1 x minus 3 is equivalent to 4 over 2x plus 1 minus a half, sorry, not minus half, minus 1, because my b was minus 1, over x minus 3. And that's the solution. Okay? Let's have a look at another question, slightly different. Okay, so this says express 2x minus 11 over x minus 4 squared in partial fractions. So this isn't like the previous question where we had two distinct brackets on the bottom, two distinct linear brackets on the bottom. This time we've got a rewriting of x minus 4 squared as, the two brackets are x minus 4 squared. You can think of it as x minus 4 times x minus 4. However, if we were to split our partial fraction into a over x minus 4 plus b over x minus 4, when I combine those, I wouldn't have needed to actually multiply these two together. So it wouldn't make sense. I would have just done a plus b over x minus 4. So that means here something else must be going on. Okay? Which wouldn't have allowed us to do just this. We've ended up with an x minus 4 squared. So we must assume that one of these two brackets must be squared. Because if one of these two brackets are squared, then that means I would have had to square my left bracket, x minus 4 squared. I've also had to multiply that by x minus 4 to make this a single fraction where I've got an x minus 4 squared involved. So there is a general rule for this, which is if you've got px plus q over ax plus b squared, in fact I've not given myself enough room for this, if you've got px plus q over ax plus b squared, you would write this as a over ax plus b plus b over ax plus b squared. Okay, so we're going to do that with our fraction here. So I'm going to say that 2x minus 11 over x minus 4 squared is equivalent to a over ax plus b, not ax plus b, sorry, a over x minus 4 plus b over x minus 4 squared. And I've used equivalent because it's technically not equal to, because we don't know our a and b, it's just equivalent to. I should have used an equivalent to sign here as well. Okay, now that I have this, I can multiply through by my quadratic, my x minus 4 squared, so I'm going to multiply everything by x minus 4 squared. So on my left hand side, that's going to cancel this out, so I'm just left with 2x minus 11, and that is going to be equivalent to multiplying this by x minus 4 squared, so a over x minus 4 multiplied by x minus 4 squared will cancel out one of the x minus 4 squared, one of the x minus 4s, but it will leave an x minus 4 on top. And then multiplying b over x minus 4 squared by x minus 4 squared is going to completely cancel it all out, giving me just plus b. Okay? So to find the solution to this, again I'm going to just substitute in a value which will eliminate one of my brackets, which I've only got one bracket anyway, so I'm going to substitute in x equals 4, which is going to give me 2 lots of 4 minus 11 is equal to a 4 minus 4 plus b, which gives me b as minus 3. Now I know b is minus 3, I can use this to help me find out my a value by substituting in just any value for x and the value that I've got for b. So because I can't eliminate my b like I did a second ago with my other method, all I'm going to do is choose any value for x let's say 0, because 0 is always a nice way of getting rid of some terms. So I'm going to say x equals 0. And I'm also going to use the b is minus 3 to help me solve this. So I'm going to get two lots of 0 minus 11 is equal to a 0 minus 4, and then my b as minus 3, so plus b, which is just minus 3, which gives me minus 11 is equal to minus 4a minus 3, which is minus 8 is equal to minus 4a, which is a is equal to 2. Now I've got my a and my b, I can put it back into the partial fraction that I was writing up here. So my final solution is 2x minus 11 over x minus 4 squared. So 2x minus 11 over x minus 4 squared is equivalent to 2 over x minus 4, and then b, which was minus 3, so minus 3 over x minus 4 squared. Done. Okay. Let's have a look at another example. So that example, we had x minus 4 squared on the bottom. Previous example, we had two separate brackets. Third example is a combination of both. You've got two distinct brackets, but one of those distinct brackets is squared. So you've got to apply the same rules for the squared plus the other one. So we can really think about this as three brackets here. So this is going to become 1 minus 9x minus 8x squared over x minus 2, 2x plus 3 squared is equivalent to a over x minus 2, then plus our second lot of stuff, which would be b over 2x plus 3 plus c over 2x plus 3 squared. Okay. Now that I've written it as this, I can multiply through by my bottom of my denominator on the other side. So we're going to multiply through by x minus 2, 2x plus 3 squared, which is going to completely cancel out the denominator on the left hand side, leaving me with 1 minus 9x minus 8x squared is equivalent to, so a over x minus 2 multiplied by this, the x minus 2's are going to cancel out, giving me a 2x plus 3 squared. On the b, one of the 2x plus 3's will cancel out, but the other one won't, leaving me with b x minus 2 with one lot of 2x plus 3. And then when I multiply c by the c over 2x plus 3 squared by x minus 2, 2x plus 3 squared, the 2x plus 3 squareds will completely cancel out, leaving me with just the x minus 2, so c x minus 2. Then we can apply the same process. We want to get rid of some of these brackets. The only problem is now that our b bracket has two different things, okay, two separate ones. If I cancel out my a by making this 2x plus 3 become a 0, it's also going to cancel out my b. And when I cancel out my c by making the x minus 2 become 0, it would also cancel out my b. So at the moment there's no way of finding the b by cancelling out the a and the c simultaneously. But whenever I cancel out a, it cancels out b, which will allow me to get my c. And when I cancel out c, it will cancel out b, which will allow me to get my a. Once I've then got my a and my c, I can use those values as a substitution with a value such as x equals 0 like I did on the last question to find b. So the first thing I'm going to do is I'm going to cancel out my c bracket by doing x is equal to 2. Okay, this is going to give me 1 minus 9 lots of 2 minus 8 lots of 2 squared, which is equal to A 2 lots of 2 plus 3 squared plus B 2 minus 2, 2 lots of 2 plus 3 plus C 2 minus 2. Okay, that's going to cancel this out, and it's going to cancel this out because 2 minus 2 is 0, and then everything multiplied by 0 is 0, leaving me with just the A term, which is 1 minus 18 minus 32. So that would be 1 minus 50, which is minus 49. So I get minus 49 is equal to 4 plus 3 is 7, 7 squared is 49. So minus 49 is positive 49A, means that A is equal to minus 1. Now I've got that, I can cancel out my A term, which will cancel out my B term simultaneously, by taking 2x plus 3 is equal to 0, giving me x is equal to minus 3 over 2. So I'm going to use that now. So x is equal to minus 3 over 2. When substituted into the equation, that's going to give me 1 minus 9 lots of minus 3 over 2 minus 8 lots of minus 3 over 2 squared, which is equal to A 2 lots of minus 3 over 2 plus 3 squared plus B minus 3 over 2 minus 2, 2 lots of minus 3 over 2 plus 3 plus C minus 3 over 2 minus 2. Okay, again this is going to cancel out my A terms and my B terms. I could have actually just written this without my A terms and B terms because that was the whole point of me substituting in minus 3 over 2, but it's just good practice to write the full thing that you're actually doing to show where things are disappearing. Okay, and that is going to leave me with minus 7 over 2 on my left hand side, which is equal to minus 7 over 2 C, which means that C is equal to positive 1. So now I know my A term, negative 1, I know my C term, positive 1. I can use those two values plus any value of x I choose to find the B. Well, any value of x other than the ones which cancelled out my terms. I can't reuse 2 and minus 3 over 2, otherwise I'm going to end up with the same situation where B is disappearing. So I'm going to use any value but those two. And the obvious one is always 0, because 0 makes life easier. So we're going to substitute x is equal to 0 in there, as well as A is equal to minus 1 and C is equal to positive 1, which is going to give me 1 minus 9 lots of 0 minus 8 lots of 0 squared, which is equal to, well, A is negative 1, so minus 1 lots of 2 lots of 0 plus 3 squared, then plus B, don't know B yet, lots of 0 minus 2, 2 lots of 0 plus 3, plus my C, which is positive 1. So 1, lots of 0, 0 minus 2. Okay, which will all cancel down to 1 is equal to minus 9 minus 6b minus 2, which gives me my 12 is equal to minus 6b, and b is equal to minus 2. Now I know my a, b and c. I can put those back into my original partial fraction. So that will become, and I've run out of space here, so I'll just rewrite it up here. So my a is minus 1, my b, my c, well my b was minus 2, and my c was positive 1. So my final solution should be that, but without obviously the blue lines crossing out the bottom values. Okay, so it's a bit longer than the last two, but it combines those two concepts together, and it's a very common style question. Okay, the next one we're going to be looking at is this, and you may look at this and go, oh, this is basically the same as the other one, but the key difference is here, the squared is not on the outside of a bracket, it's on the inside, which means we have to apply a very different rule, and that rule is px plus q, ax plus b, cx squared plus d. If you want to rewrite this with your a's and your b's, you've actually got to rewrite this as a over ax plus b plus plus b x plus c, all as one fraction, over your cx squared plus d. So if this squared is on the inside of a bracket, when you split your two fractions, you've got to actually include a term involving x on top, as well as another value added to that not involving x. So when we rewrite this, one that we've got here, we've got 8 plus 2x minus x squared over x minus 1, x squared plus 2, and that is going to be equivalent to a over x minus 1 plus bx plus c over x squared plus 2. Okay? Once we have it written as this, we apply the same things that we've been doing this entire time. So we're going to multiply through by x minus 1, x squared plus 2, giving us 8 plus 2x minus x squared is equivalent to a x squared plus 2 plus bx plus c times x minus 1. Okay? The thing that I would do though is I would consider that I can actually split this fraction here to bx over x squared plus 2 plus c over x squared plus 2, which means I can rewrite this as 8 plus 2x minus x squared is equivalent to a lots of x squared plus 2 plus bx x minus 1 plus c x minus 1. Okay, it's also basically saying the expansion of this is bx times the bracket and c times the bracket, without then expanding those brackets. Okay, now that I've done that, I can use this form to find my A's, B's and C's like I did with the previous ones. So, first of all, I'm going to cancel out my B and C term by making the x minus 1 bracket become 0. So to do that, I'm going to say that x equals 1, which is going to make B's and C's disappear. So that means I've got 8 plus 2 lots of 1 minus 1 squared, which is equal to a 1 squared plus 2 plus b lots of 1, then 1 minus 1 plus c lots of 1 minus 1. Okay, b's and c's are going to disappear, leaving me with the solution, which is, well, the solution for a, which is 9 is equal to 3a, so a is equal to 3. Okay, now that I found a, I need to use this to find one of my other terms, but I cannot get rid of my, I can't just eliminate a, because if I eliminate a, that's still going to leave me with b and c, which means that I've got two variables which I don't know. Okay, so what I'm going to do is I'm actually going to eliminate the b term by using 0, which is still going to leave me with a and c, but because I know my value of a, I can then substitute in my value of a to find c. So here I'm going to eliminate b. So to eliminate b, I'm going to make x equal to 0, because b times 0 minus 1 is going to be 0 because of all the multiplying by 0. And then I'm going to use my a equals 3 to allow me to find c. So I've got 8 plus 2 lots of 0 minus 0 squared is equal to my a, which is actually 3, lots of 0 squared plus 2 plus b, lots of 0 minus 1 plus c, lots of 0 minus 1. Okay, that's going to give me on my left hand side just 8. Okay, 3 lots of 0 squared plus 2 becomes 6. B disappears and it leaves me with 6 minus c. Okay, which gives me minus 2 is minus c, which means that c is 2. Oh no, sorry. Slight mistake there. Can't do 8 minus 6. 8 minus 6 is positive 2 minus c, which means that positive c is negative 2. Okay, now I've got my a and my c, I can use this to help me find my b value, okay, by substituting in another value of x, but this time the value of x can't be 0 or 1, because I've already used 0 and 1 to eliminate my b. It's got to be any other value which will fit in here. So I need to just choose another x value. I'm going to choose negative 1. Okay, and then I can use my value of a and my value of c to allow me to find b. So I'm going to choose minus 1. I could have chosen a different value, but I chose minus 1. So x is equal to minus 1, giving me 8 plus 2 lots of minus 1 minus 1 squared is equal to my a, which is 3, lots of minus 1 squared plus 2 plus my b, which I don't know, lots of minus 1, minus 1, minus 1. Okay. Plus c, which c is a negative 2, so c is minus 2, so it shouldn't actually be plus. That should just be minus 2. Lots of minus 1, minus 1. Okay? Which gives me, on my left hand side, that is going to become 5. And that is equal to 9 plus 2b plus 4, which will become minus 8 is equal to 2b, so b is equal to minus 4. And again, once I've got my b, c and a, I can put that back into my original impartial fraction. So a is 3, b is minus 4, c is minus 2. So up here, I would say that a is 3, b is minus 4 and c is minus 2. So I'm going to say plus, well, there's two ways I can do it. I'm going to just say plus still, but plus b and c as minus 4 and minus 2. So minus 4x minus 2. Okay? And again, I'm writing up here because I've just run out of space. I would have written it elsewhere, which is better than trying to replace your answer at the top, so that way the examiner can read fully through and get the answer at the bottom, not give the answer and then show where the answer came from. So that's the final solution there. Okay, I could rewrite this by taking the minus out of the top part, giving me the solution of 3 over x minus 1 minus positive 4x plus 2 over x squared plus 2. That is probably the better form of a better way of writing this. So if you get a negative in front of the x up top, I would take the negative out into the plus and replace plus with a minus. If the second thing here, if the minus 2 was positive 2, I would still do that, but my positive 2 here would become minus 2. It's just better not to have a plus and a minus next to each other. It's just good mathematical practice. Okay? So, the last thing we're going to look at is this. And this question here implies two things. The partial fractions, but also improper fractions. As the question you currently have, the numerator is greater than the denominator. Okay? So, if the degree of the numerator and denominator are, if the degree, of the numerator is greater than or equal to the degree of the denominator, then you can express it as an improper fraction. Is an improper fraction, which you can express as a mixed algebraic number, or algebraic fraction type thing. And then you would then be able to split those into partial fractions. So, first step here is to find the remainder, so we can split this into two separate fractions. So we're going to divide the top by the bottom. So we're saying how many times does x squared plus 2x minus 3 go into 2x squared plus 5x minus 11. So what do I need to multiply this by to get rid of my 2x squared? I need to multiply it by 2, which is going to give me 2x squared plus 4x minus 6. When I take them away from each other, I'm left with just x minus 5, which means another way of writing this fraction here is 2 plus x minus 5 over x squared plus 2x minus 3. Okay, now that I have it like this, I can express that as partial fractions. However, you'll notice that the quadratic on the bottom isn't in brackets. So the first step is to actually factorize down that quadratic into double brackets. So that's going to give me 2 plus x minus 5 over, well, x plus 3 and x minus 1. Now that I have it like this, and now that I have it like this, we can split this into its partial fractions. So I'm going to say that this, so 2 plus x minus 5 over x plus 3 x minus 1 can be rewritten as 2 plus a over x plus 3 plus b over x minus 1. Okay, so the 2 plus there is there because it exists. I can actually get rid of that for the purposes of finding my a and the b. It's not needed here, so I'm just going to ignore that for now for finding a and b, but once I found a and b, I will still need it for my final solution, which is going to look like this 2 plus everything. But just for all the solving, it will cancel out. So I'm going to multiply through by my bottom bracket. Oh, I didn't need brackets on that one. So I'm going to multiply through by my numerator of the x minus 5 over x plus 3, x minus 1. So that's going to give me a thing which looks like x minus 5. Sorry, x minus 5 is equal or equivalent to a x minus 1 plus b x plus 3. And now it's just basically example 1 all over again. Very straightforward. Cancel out my a, cancel out my b. So to cancel out a, I'm going to say x is equal to 1, giving me 1 minus 5 is equal to a lots of 1 minus 1 plus b lots of 1 plus 3, which is minus 4 is equal to 4b, so b is equal to minus 1. Then I'm going to cancel out my b term by making x equals minus 3, which is going to give me minus 3 minus 5 is equal to a minus 3 minus 1 plus b minus 3 plus 1. Sorry, minus 3 plus 3. B is going to disappear. Minus 3 minus 5 is minus 8. Minus 3 minus 1 is minus 4, so minus 4a. So a is equal to 2. Now I found a, now I found b. I can put back into that original form and make the original question equivalent to this in partial fraction. So 2x squared plus 5x minus 11 over x squared plus 2x minus 3 is equivalent to 2 plus 2 over x plus 3 and minus, because b is minus 1, minus 1 over x minus 1. And that's the solution. Okay. So partial fractions is one of those slightly more tricky, more fiddly things with a lot of working that's needed to get to the answers. But hopefully you understood that to some degree. and you can have a go at some questions now. If you struggled, maybe go back and have another quick look at something, and one of the examples again. And good luck with the questions, and I'll speak to you again soon.